What is up, YouTube? And welcome to episode 37 of the Chaos Daily. So, fun story for you. Yesterday I was working on that ridiculous CL1201 mega plane. It's like best described as an aircraft carrier. Anyways, back to the story, right? So yesterday I was doing that sort of stuff. And I was in my patron exclusive Discord, hanging out with my patrons. And Jotham's like, hey, have you tried chucking that into XLFR5, I think. Why did they name it with a bunch of annoying consonants? Why couldn't they just name it like they did with OpenVSP? That's an easy thing to say. Anyways, it's basically free software that people use to design aircraft and get meaningful results of center of lift and center of this and blah blah blah. You know what I'm talking about. And I was like, yeah, that's a really good idea. I should probably take some time to go have a look at these softwares and see how they work and try and load some stuff in there. And one thing led to another. And I hang out in a couple of different Discords. And the other one I'm hanging out in is the Advanced Rocketry crowd. That's where, Joe Barnard hangs out. The guy that builds the really cool rockets. Yeah, he hangs out there. And anyways, so I'm in there and I'm hanging out with those guys, and one of the guys in there says, why aren't you using CFD? Why aren't you using Autodesk CFD? And I was like, I can set the wind tunnels up and whatnot, but I don't know how to activate the thing. There's a checkbox somewhere I'm not clicking. I can't get meaningful results. I can't look at the numbers. It's not giving me numbers. I can look at the visual representation of the data and I can try and work stuff out from that, but it's not giving me the numbers. It's not telling me what the total lift is, the drag, all that sort of stuff like it did in flow design. And he goes, oh, that's easy. It's this checkbox. And then he takes a couple of screenshots and sends them to me, and I'm like, oh my god. That was a real Picard facepalm moment. I was like, really? It would be the one that's like, that I thought it meant something else. I never went into to go look at and see how it actually works. So I never utilized it, never played around with it. Because I assumed it's named something. It's named wall calculator. And the way that the image is described, I'm assuming it's for calculating the forces and the metrics or measurements along the wall of a cube or your wind tunnel or whatever. Like, I don't know. It's not very well described in the name, but coming to think of it, it totally makes sense now. Like, that's what it does. That I've actually gone through and looked through the settings of it. Anyway, so I started playing with that yesterday, and yeah, long story short, I put the albatross into it to verify the albatross, and oh boy. So let's jump into CFD, not Inventor, and have a look at what we have discovered. So here we are. So I've got two of them running, okay? I've got two of them running. There's two different ones. because apparently one of them only uses 30% of my processing power, so I'm running two simulations at the same time. But hey, that's just the way it rolls. So I did two of them. Yesterday I just did the one. I did this one, which is a neutral angle of attack. It's a zero angle of attack, 20 meters a second flow. Just wanted to see what it does. And by turning on this one, and you set it up, and you select the thing, and you tell it to calculate. You come in here with your results. You click this button and this button, and then bam, you get your results. So there we go. Running this, I've run it for 300 iterations. Normally I try and run it at least to 500 to stabilize it, so you can see how the graph is sort of all over the place. It starts to stabilize after 300. So as it gets to 300. So when I look at this here and I go, okay, it is producing 16 newtons of force, accumulated force for all the surfaces over the whole aircraft. It's creating 16 newtons of force, and I can see exactly where that force is, and we're going about the y-axis, which is the y-axis, it's the up-axis. So I know exactly where that is. It's a little bit off-center. Now, I've come in here and I've used this point. This is not the proper way to use this tool, but I can use it to determine a point based on those other numbers. So here I've just set it up as the center of lift. You can see it's a little bit off center, so I'm going to make sure that I set the motor up so that the motor torque, the rotational torque from the prop, is opposite to this. If you look at the vorticity of the flow around the nose leading up before the wings, it starts to actually, it doesn't just come smooth over it, it actually wants to spiral, and I can actually show you that. So you can see there how the flow is wanting to rotate around the nose. That's what's giving me that really off-center lift, that strange sort of rotation. So that's really cool. But the fact that I can now come in and I can get these numbers, I can see where my center of lift is, I can see what my lift is, and I'm getting a lift of 16 newtons, which is roughly was it, 1.5, 1.6 kilograms of lift, and I'm expecting the aircraft weight to be about 1.1, 1.2 kilograms-ish, maybe 1.3. So it's got more than enough lift, and this is at neutral, right? This is 0 angle of attack, and it's going to cruise at 20 meters a second. I'm going to need to now run some simulations at 10 meters a second, so I can see how it starts to perform at lower speeds. 20 meters a second is not the fastest that I can go with this prop. This is a 6-inch pitch prop. One of these produces roughly 1.5 kilograms of thrust, and my all-up weight's going to be 1.2. Let's say 1.3. So I've got 1-to-1 thrust to weight ratio on this thing. I've got excellent lift characteristics, and when I started doing the simulation for the 5 degrees angle attack, I noticed something really cool. We're looking at nearly 4 kilograms of lift at 5 degrees angle attack, which means this tells me that this thing is going to be snappy. If you start to turn, it's just going to go. So I need to actually, where I was paranoid about the wings folding, remember that? Remember that when I said I'm paranoid about the wings folding? Because I'm so paranoid about folding wings. This is where that comes to play in, because if I'm producing 4 kilograms of lift at 5 degrees angle of attack, this thing's going to want to go up and right, change its vector to match its angle of attack. So that's really good. That's really impressive. I've done a number of other tests. Now that I have this, now that this is working, I can now utilize CFD to get anything I want. Well, not anything I want. I still need to learn how to do rotating regions so that I can simulate EFDs and props and stuff like that. That's going to be really cool when I figure out how to do that. Now that I've got this, I can chuck the long easy in here, and I can get all of that aerodynamic data and information that I wanted on the long easy that I was trying to get before, where somebody was kindly helping me out with that by putting it into his open sim software and stuff, and not really getting into it because it's not designed to handle that kind of fuselage. And that's why I'm leaning towards using the CFD to do this, because this is the proper tool to use to do this sort of thing. It's not just an open source tool that's free for everyone to use. They're perfectly fine and powerful, but they have their limitations. So somebody brought this up on Twitter, and that is verifying the results. So how do I know that these are the real numbers? Like, these mean anything? Is this just rubbish? That's totally understandable, right? That's something any good scientist or engineer needs to verify their results. They have to get data from multiple sources on the same subject that verify within a certain region of error. Now, the issue I have is that I design my planes in Inventor, and they are mostly sometimes freeform by hand. I don't use listed aerofoils. I don't go out and search for an aerofoil to do something. I think about what the thing is going to do, what its parameters are, what the performance is that I want, and then I think in my mind, okay, now what airfoils do I know and what sort of shapes do they have for those kind of envelopes, and then I basically freestyle from there. So I have not a extensive knowledge of all airfoils and their names and stuff, but I know all the different shapes and stuff and what their performance characteristics are within a certain range of error. And I use that then to freestyle what airfoils I design for what the thing needs to do for whatever flight envelope I expect it to have. The problem I have is that because I do this freestyle design, whenever I want to take one of my planes and put it into one of these open source sim softwares, I have to painstakingly recreate the aircraft, the fuselage. A lot of the times I design stuff with blended wing body shapes where it's not just a wing and a fuselage and they meet. It's all blended and curved, and like I go in and meticulously change the shape of stuff for aerodynamics and to reduce drag. So to painstakingly recreate that in these softwares is a lot of time and effort. And then there's also the learning how to use those softwares that I still need to do. So there's a lot of upfront work that I have to do before I can even think of getting information from one of those pieces of software. And then the other thing is, depending on how close I can recreate the design in one of those open source softwares to my design, is hugely dependent on the validity of the results. How divergent will the results be based on the accuracy of my recreation in the other software? And honestly, all of that work, just for the fact that there might be divergent results because of minor changes in an airfoil or the skin of the hull, it's not really worth it. It's a lot of work and effort when I have software that is it's used in industry for doing all kinds fluid flow dynamic simulations. This is powerful software. Learning how to use it properly is half the battle. right? And the same with these open source software. Learning how to use them probably is half the battle. I've been working to learn how to use this software for months now, and I'm getting to the point now where I can actually confidently say when I do something in it that what I'm getting is accurate and not just I've not selected the right checkboxes here or not set something up correctly. So far, from what I've got now, I'm at a point where I can say, okay, I am happy with the results that I'm getting. These numbers look genuine, within what I expected when I modeled the plane in the first place. Like in my mind, I keep saying this, I freestyle these designs, but in my mind, I have a flight envelope in mind. Now, it's not something I write down on the back of the napkin like they used to do, like Kelly Johnson and those guys back in the day. They would sit down and they would write down the flight envelope parameters that they wanted for whatever they were designing. And then they go and design a whole bunch of different designs and then do tests on those designs to see which one closely matched to the envelope that they were required to make. I don't do it that way. I don't have those kind of limitations. I can go, right, I want this design and I want it to be as close to this envelope as possible, and then I can check it now and see how close I was. So let's have a look at this is to my expectations of what my envelope. Now, I never said anything, so you're just gonna have to take my word for it that like it's either gonna be close or not. And surprisingly, it's pretty close, but it's outperforming in some areas that I didn't want it to perform. So it's going to be a bit more. It's got a few more characteristics that you would find in an F3K or a pylon racer, something that has a lot more, that needs a lot more rigidity in the airframe, because any maneuvering that happens with it is going to be very snappy. It's going to be a very responsive aircraft. And I was looking for something that would be a bit more sedate and casual and a bit more relaxed. And I'm thinking at slower speeds, this aircraft will still behave that way. But at 20 meters a second, this thing is on rails, and I'm super excited. Like, I can't wait to start getting rotational regions going, because that's another big step forward. That means I can start simulating EFDs and props and stuff before I even print them and put them in a test rig and start getting the thrust values. And that will be even better when I can start designing my own EDF blades and putting them up, mounting them on a motor, stick them in a test rig, and in the software I can say, right, it's going to generate this much thrust, put it in the rig, and see how much thrust we get. And that's going to be super exciting, but that's way down the line. I've been looking at what it would take to build a thrust rig or to buy a thrust rig. And I think I'm just going to buy one, because I found one on Baggood that's like $100 and something odd dollars. It's a really good test rig. It's easily modifiable to my needs, but that's $100 and something dollars I don't have. So maybe down the line we get some more patrons going and we can get something like that on the go. There's still plenty of other projects and stuff to be working on in the meantime, especially with getting the resin printer set up. We'll leave it there for today. I'm like super excited. I'm loving these numbers. I mean, the fact that it's verified that the plane has the right center of lift to where I expect the CG to need to be, where I've got the battery placed, and everything is going to be great. I'm super excited. So yeah, we'll end the video here. Make sure you hit the like button if you haven't already. Make sure you're subscribed. Go check out my Patreon if you can. It's super helpful. It'll help me get sort of these projects off the ground quicker. And so as always, I've been Chaos. And until next time, expect the unexpected. And I'll see you guys later. And a special thank you to all my patrons that help support the channel. If you would also like to support the channel, there's a link in the description.